In this video, we learn how to follow TCP streams in Wireshark. This is a powerful feature for penetration testers because it allows us to reconstruct entire conversations between a client and a server, whether it's web traffic over HTTP or FTP logins in plain text. I've already started Wireshark and I'll select my active network interface to begin capturing traffic. To generate some HTTP packets, I'll open a browser and visit neverssl.com. This site uses plain HTTP, making it perfect for demonstration. Now back in Wireshark, I'll stop the capture. Now let's only filter TCP packets by typing HTTP in the filter bar. Here I'll pick one of the packets from HTTP session. This is the starting point for following the entire TCP stream. Right-clicking the packet and choosing Follow and TCP stream. Wireshark now reconstructs the entire conversation. In this window, we can clearly see the client requests and the server responses. Notice here, the client sends an HTTP GET request, including headers like host and user agent. The server responds with a status code of 200 OK, along with content headers and the HTML page itself. This is extremely useful for penetration testers because it allows us to view entire web transactions, even when spread out across multiple packets. This also works with FTP traffic. If we capture an FTP login following the TCP stream, shows the authentication flow. This immediately highlights why unencrypted protocols like FTP are insecure and why attackers can so easily sniff credentials. At the bottom of the TCP stream window, there are more options. We can switch between different streams using this drop-down, very useful when analyzing multiple connections. We can also change how the data is displayed as ASCII text, raw byte stream, or even a hexadecimal dump, depending on what we are investigating. To summarize, Wireshark's follow TCP stream feature gives penetration testers a way to see the entire conversations, not just individual packets. This makes it easier to reconstruct sessions, identify sensitive data leaks, and demonstrate risk in using insecure protocols. In real pen tests, this technique is often used to recover credentials, inspect unencrypted API calls, or trace attacker activity. Thanks for watching.